What's up guys, welcome back to another video here at Chief Academy, and today we'll be going through probability trees. Please like and subscribe if you haven't already, because I promise you it is this easy. Our learning outcomes for today is to understand how to draw probability trees and how to use and answer. It's also to solve probability trees exam questions. So, what are probability trees? Probability trees, or tree diagrams, are a way of showing combinations of two or more events. Each branch is labelled at the end with its outcome, and the probability is written alongside the line. In this lesson, we will focus on solving probability trees exam questions and understand whether the event is independent or not. So, here is an example of a probability tree. As we said before, tree diagrams are a way of showing combinations of two or more events, and each branch is labelled at the end with its outcome, and the probability is written alongside the line. The tree diagram in blue is how you set out one which has two answers. Two events are independent if the probability of the first event happening has no impact on the probability of the second event. For example, the probability of rolling a 6 on a die will not affect the probability of rolling a 6 the next time. The scores on each roll are independent. However, if you roll a die, say, and get 3, but then you're not allowed to get 3 the second time, then it is affecting the probability of rolling it next time, because you are taking away one of your answers. So instead of being 1 in 6, it becomes 1 in 5. And that is when it's dependent. And if you do the higher paper, you'll need to know about that. But we won't cover that in today's lesson, as we'll just focus on the independent, which always comes up on a foundation paper. Once again, it's that time to have a go at some Math Genie exam questions. Have a go, pause the video, and unpause when you've done. Tina has 2 bags of counters, bag A and bag B. There are 5 red counters and 3 blue counters in bag A, and there's 4 red counters and 5 blue counters in bag B. Tina takes at random a counter from each bag. Complete the probability tree. So, first, in bag A, we know there's 5 red and 3 blue, meaning overall there's 8. So we do 5 over 8 for the red and 3 over 8 for the blue. Now for bag B, we know there's 4 red and 5 blue, meaning there's 9 overall. So 4 over 9 for red, 5 over 9 for blue, and then we do it again. Now in part B, we're asked to work out the probability that Tina takes 2 blue counters. So we fold the lines, and we go blue the first time, then blue the second time. That would mean we do 3 over 8 times 5 over 9, as we're doing the probability here. And that would get us the answer of 15 over 72. You could either leave that in a decimal or percentage form, but as we've worked with fractions, keep it in the fraction. But when you deal with probability, you can give it in all 3 forms. With probability, practice is the way to understand if you don't. It will come up on both foundation and higher papers, and calculator and non-calc. Just remember that probability has a max of 1 or 100%, and all must sum to it. Say if you've got one probability which is red, which is 5 over 9, the only possible other one if you're dealing with 2 is going to be 4 over 9. It's going to have to sum to 9 over 9, and if you don't, then something's gone wrong. You will also have to draw your own probability trees in your exams with some questions, so make sure that you leave enough room for yourself to draw. Here are some more exam questions for you to have a go at. Have a go, pause the video, and unpause when you've done. So, John plays a game where he can win, draw, or lose. The probability that John wins any game is 0.5, and the probability that John draws any game is 0.3. John plays 2 games. Complete the probability tree diagram. So, as I said before, it must sum to 1, and we've got 0.5 and 0.3, which sum to 0.8. So the probability that John loses any game is going to be 0.2. Now, notice how it says any game. This is an independent variable because it does not change, meaning for our second game, he has all the same percentages he would in his first game. So the win's going to be 0.5, draw is going to be 0.3, and loss is going to be 0.2. And this is for every single one. Now in part B, we are asked to work out the probability John wins both games. So we look at win for the first time, which is 0.5, and win the second time, which is also 0.5. So do 0.5 times 0.5, and you get the answer of 0.25. Now, here are some of the hardest exam questions you'll probably be asked on a foundation paper for probability trees. Have a go, pause the video, and then pause when you've done. So, Mimi has 2 bags. In the first bag, there's 3 red balls and 7 green balls, and in the second bag, there's 4 red balls and 5 green balls. Mimi takes, at random, a ball from the first bag. She then takes, at random, a ball from the second bag. Work out the probability that Mimi takes 2 green balls. Now, here you would have had to draw on your own probability tree with a red and a green, and this is what it should look like. So, red probability would be 3 over 10, and green probability would be 7 over 10 for the first one. But as she's got 9 in her second bag, it would be 4 over 9 for red, and 5 over 9 for green. Now, we're asked to work out the probability that Mimi takes 2 green balls. So we do 7 over 10 times 5 over 9, which does get you to 35 over 90, but this can be simplified down to 7 over 18. Don't worry if you put 35 over 90, because you will get the mark unless it tells you to put it in its simplified form. Then you would have to simplify it down to 7 over 18. Here is another exam question for you to have a go at. Have a go, pause the video, and then pause when you've done. Lola plays a game where she can win, draw, or lose. The probability that Lola wins any game is 0.6, and the probability that Lola draws any game is 0.1. Lola plays 2 games. Work out the probability that Lola wins exactly 1 game. Now here you would have to draw 3 tree diagrams instead of 2, and it should look something like this, where you have win, draw, and loss, and your loss is 0.3, because 0.6 plus 0.1 equals 0.7, and then 1 minus 0.7 obviously equals 0.3. And as it says any game, this is equal for every single one. Now, we're asked to work out the probability that Lola wins exactly 1 game. This means that we have the probability of a win-draw plus a win-loss plus a draw-win plus a loss-win. Can't be win-win, as it states exactly 1 game they win. So if we work out all the probabilities and then we add them up, this will be our final answer. Now, if you can see and work it out, a win-draw will have the same probability of a draw-win. Same for a win-loss and a loss-win. So if you just work out a win-draw, times it by 2, and then a win-loss, times it by 2, and then add them together, you'll get the same answer, so don't worry. And as a final answer, you should get 0.48, or 48%, whatever you want to leave it in. And that is your final answer. And that, ladies and gentlemen, is the end of today's lesson. And I did say it was that easy. Thank you very much for watching. Please like, subscribe if you haven't already, and I will see you in the next one.